This is the Asiga, a post-curing system for 3D printed photopolymers where speed, reliability, and quantifiability are required. It's ideal for the manufacture of medical devices, including those in dentistry and audiology. In order to appreciate some of its unique features, I want to describe a problem that you may have already experienced in your own kitchen. If you place a potato in a microwave oven, it'll take a particular amount of time to cook. If you place 2 potatoes in the same oven, it'll take longer to cook because the generated microwaves now have to be shared between the 2 potatoes. I call this the 2-potato problem, and it reminds us that a microwave oven is not a magical box with fixed cooking times for any objects placed inside it. The cooking time depends on the size and the number of things you place inside. Light-based post-curing devices also suffer from the 2-potato problem, as placing multiple objects inside such a system, or even placing larger objects compared to smaller ones, results in sharing the generated light across more surface area, and a different dose rate is then applied to the surfaces. Despite this, many curing systems refer to curing time as the only control parameter, which we can now appreciate as problematic. This results in post-curing systems being treated as black boxes, where settings from one system cannot be easily translated to another. In addition, there are process challenges such as oxygen inhibition, where ambient oxygen interferes with the polymerization reaction, and temperature effects that can greatly impact the curing of parts or their appearance. The Asiga takes a new approach, where measurable physical phenomena that affect curing are defined and controlled. A quantifiable prescription for post-curing should include the optical dose, temperature, and the pressure at which curing is performed. For example, one material may require 5 joules per square centimetre of UV light exposure, a temperature of 60 degrees Celsius, and a vacuum pressure of 10 millibars absolute. This is exactly what we've enabled in the Asiga. It allows a clear curing prescription to be performed in a repeatable way. You can specify these values directly on the control panel, or you can choose from a library of curing profiles for different materials. At the heart of the Asiga is a glass vacuum chamber surrounded by ultraviolet LEDs on the top, bottom, and all sides, so you don't need to turn parts over. The glass chamber has a diffusing surface, and the entire structure is further enclosed by a diffusing reflector. The result is a uniform distribution of light inside the chamber. A second important feature is an internal radiometer array for measuring the intensity of light inside the chamber. Integrating the intensity across time allows the precise dose of optical energy delivered to the objects to be measured. The system includes an internal high-performance vacuum pump, which reduces the oxygen concentration inside the chamber to prevent oxygen inhibition when curing. This achieves the performance of inert gas curing systems without the cost and hassle of nitrogen canisters or generators. The Asiga incorporates an infrared heating system and temperature sensor for precise temperature control from ambient up to 80 degrees Celsius. The system also has a convenient gesture opening hood, which is perfect for when your hands are full. Let's take a look at the back of the Cure. There are 2 gas ports. One is an inert gas input port. Although the onboard vacuum pump removes the need for inert gas in most applications, there may be existing certified processes that require inert gas. When using inert gas, the chamber is first evacuated by the vacuum pump before filling with inert gas. This ensures minimal waste of expensive gas. It's also possible to automatically repeat this process several times, allowing remnant gas concentrations of less than 1 part per million to be achieved should you need it. The other fitting is a vacuum acceleration port and relay output. This allows connection to and control of an external high-capacity vacuum pump to reduce vacuum pull-down time to seconds. The Asiga is fully networked with Ethernet and Wi-Fi to seamlessly integrate into your workflow. Curing instructions are automatically sent to the curer for every print job to simplify operation and minimize operator error. To summarize, the Asiga Cure is a light-based post-curing system for measurable delivery of optical dose, temperature, and vacuum. It's ideal for medical device manufacturing. It has no ongoing operating costs and is essentially maintenance-free. It's available now, so contact your Asiga reseller for more information.